WAEC theory question 1 says, the time T taken to buy fuel at a filling station varies directly as the number of vehicles V in a queue and varies inversely as the number of pumps P available at the station. In a station with 5 pumps, it took 10 minutes to fuel 20 vehicles. Find the relationship between T, P, and V. Now, looking at this question, it's a variation question. But what kind of variation is it? There are basically 2 types of variation that has 2 variables. Either it is partial or joint variation. But in this question, the word partial or partly varies is not there, so it's a joint variation. Now, the time T taken to buy fuel at a filling station varies directly as the number of vehicle V. So we know our joint variation will write our T varies directly as V, that's number of vehicles in the queue, and varies inversely as the number of pump P. Then times, when it's joint variation, the variables on the other side are linked by multiplication, so we have it as times 1 over P since it is inverse. In a station with 5 pumps, it took 10 minutes to fill 20 vehicles. If you're very good with variation, this part of the question is given to us to find our constant K. These are the 2 variables that vary with T. Next, we can now write T equals K times V times 1 over P. We know it's T equals KV, that's K times V is KV times 1, that's still KV, over, you can have this over 1 and this over 1, so we have 1 times 1 times P is P, so you have it over P. Now remember, we're given certain values. We have a station with 5 pumps, so we have pumps, P is 5, we have time, that's T is 10, and we have V, that's vehicles, there are 20 of them. 5 pumps, time is 10 minutes, then the vehicle is V. We use these 3 values to find our K, which is a constant. The T can change, the V can change, the P can change, but the K is constant. So we have it as, we know our T is 10, so we have 10 equals our K is unknown, then our V is 20 over our P, which is 5. With this, we find our K, which is a constant. We can say 10 over 1, then we cross multiply. We say K times 20 times 1, that's K 20 times 1 is 20K, or K20, equals, on the other side we have 10 times 5, 10 times 5, so we have 20K equals 10 times 5 is 50. Since we're looking for K, we divide both sides by 20, so we divide both sides by 20. 20 cancels 20, we're left with K equals 0 cancels 0, 5 over 2. Our constant is therefore 5 over 2. Since we know our constant is 5 over 2, we go to this part of the equation we created where we have T equals KV over P. Well, we know our K is the constant, and we found out our K is 5 over 2, so we write it T equals KV over P. Knowing that our K, this K is 5 over 2, we can write T equals 5 over 2 times V over P. It is allowed because this is also K over 1 times V over P. Or we can say K times V over P. Still the same thing, since we know our K is 5 over 2. So our T is equals to 5 times V is 5V over 2 times P is 2P. Therefore, to answer the first question, the relationship between T, V, and P is T equals 5V over 2P. That's the answer to our first question. Question B says, find the time it takes to fuel 50 vehicles at the station with 2 pumps. Now we know the relationship between T, V, and P is T equals 5V over 2P. We have the number of vehicles are 50 and we have 2 pumps, and we're asked to find the time. Insert V into the equation and also P here. So we have T equals 5 times, our V is 50 over 2 times, and now our P is also 2. We can say 2 here 1, 2 here 25. We can cancel it. Our T equals 5 times 25 over 2, which is 5 times 25 is 125 over 2. T equals 125 over 2. This is an improper fraction. We convert it into mixed fraction. That's 62 whole number 1 over 2 minutes. We can leave this as our final answer, or we can break it down into minutes and seconds. So we have 62 minutes, and half of a minute is, to convert to seconds, will be half times 60 seconds. Since for you to convert half minute to seconds, we must multiply half by 60, which is 2 here 1, 2 here 30. So we have T equals 62 minutes 30 seconds as our final answer. C says find the number of pumps required to fill 40 vehicles in 20 minutes. The question says find the number of pump P. So we know our P is unknown. The number of vehicles as V is 40 and the time is 20 minutes. We know the relationship between T, V and P is T equals 5V over 2P. Now we're asked to find P. We know our T is 20 equals 5 times our V is 40 over 2 times P, or 2P. We can say 2 here 1, 2 here 20. So we have 20 equals 5 times 20 over P. At this point, you can say 20 over 1, then we'll cross multiply. So we have 20 times P. We have 20 times P equals, on the other side, 1 times 5 times 20. We know 5 times 20 is 100. So we say 100 times 1, that's 100. We divide both sides by 20. We say 20 cancels 20. We have P on this side equals 20 here 1, 20 here 5. So P is 5. So we have 5 pumps. Our final answer.